Today we're going to continue with properties of limits, and we're going to look at, these are all ones that I got off of AP Central. You're welcome to use that anytime. I will say I steal problems from them every now and then. These are ones that I thought were like, when I first looked at each one of them, I was like, oh, that's a little bit ugly. But they kept asking them over and over again, and I'm like, that means they expect people to know them. So we're going to dive in and take a look at these. Okay, each one of these represents something that's just a little bit different. Now I'm going to have to make this a bit smaller to see all the answer choices, but you have it on your page, so you should be okay. All right, so this is one of their examples. The graphs of the function f and g are shown in the figures above. Which of the following statements is false? So let's take a look. Is the limit as x approaches 1 of f of x equal to 0? Yeah, that's pretty obviously true. The limit as x approaches 2 of g of x does not exist. What? No. That's true. Why doesn't that limit exist? I'm sorry? So tell me don't in general terms, tell me specifically, using the right terminology.
The limit g of x as x approaches 2 from the left does not equal the limit as x approaches 2 from the right of g of x.
Perfect. I knew you could do it. All right, start thinking in those, don't think in kind of mushy terms. Be specific. Yeah, the limit as x approaches 2 from the left of g of x is not equal to the limit as x approaches 2 from the right of g of x. So that's true. Then we get to things that get a little weird. Specifically, part C. The limit as x approaches 1 of f of x times g of x plus 1 does not exist. Well, what's the limit as x approaches 1 of f of x? 0. What's the limit as x approaches 1 of g of x plus 1? It doesn't exist. Is 0 times doesn't exist? Remember that the theorem we had said if those limits exist, we can multiply them together. It didn't say what happens when they don't exist. We're going to come back to this part. Let's go on to part D. What's the limit as x approaches 1 of f of x plus 1? It looks like it's about -1, and actually it's a little lower than that. But it doesn't really matter for this. It only asks, does it exist or not? It doesn't ask for its value. So that part exists. At 1, as x approaches 1, does the limit of g of x exist? Yeah, and it looks like it's 1. So this is some number times some number. This is true. This one must be false. And you're like, well, wait a minute. How can that one be false? Because you can't multiply 0 times does not exist. Because does not exist is not a number. So here's what we're going to do. You're like, well, what can I do with this? Remember, a limit will exist if its left-hand limit and its right-hand limit agree with one another. So here's what we're going to do. We're going to take the limit as x approaches 1 from the left of f of x times g of x plus 1. As x approaches 1 from the left, what does f of x approach? I heard one person say it. 0. I like getting lots of people to say things. as x approaches 1 from the left, what does g of x plus 1, in other words, we're going towards 2 from the left. What does g approach there? Pardon? 1. Yes or no? Okay, so as x approaches 1 from the left, I'm going to have values just a little bit less than 1. So let's say 0.99. Add 1 to that, 1.99. When I'm at 1.99, what sort of g values am I getting? 1. What is this equal to? 0. What about the limit as we approach x from the right? As we approach 1 from the right, what does f of x go towards? 0. And as we approach 1 from the right, what does g of x plus 1 approach? -1. And what's that equal to? 0. The left-hand limit exists, the right-hand limit exists, and they agree with one another. This limit is equal to 0. This is the one that's false. I will tell you, the first time I saw that problem, I was like, what the heck? And then I thought about it for a little while and went, oh. Any questions? I have a couple people that are staring real hard at something.
Can you explain the words that you, sorry, can you explain the words that you said about, like, if the left-hand limit and right-hand limit exist? What did you say about those?
Oh, the limit as x approaches 1 from the left of this function is equal to 0. And the limit as x approaches 1 from the right of that same function is equal to 0. If the left-hand limit and the right-hand limit agree with one another, that's the limit.
Okay.
So since the left-hand limit exists and is equal to 0, and the right-hand limit exists and is equal to 0, the limit is 0. Yes?
So, I understand, but would it be possible if you have 0, if something like that happens like that, and you have some limit as x approaches 1 of the f of x equals 0 and g of x plus 1 do not exist, can you just multiply it by 0 and whatever multiplied by 0 is 0?
Because the problem is that it's possible, now this is a pretty simple function, but it's possible to have something over there that doesn't exist for some other reason, like it goes to infinity or to negative infinity or something, and that would change everything. So yeah, you can't just go, it's 0 times, I don't know what this is, therefore it's 0. The problem is the I don't know what it is could be something that might cancel out the 0. Okay? All right, let's move on. Okay, the graphs of the function f and g are shown on the interval from 0 to 5. Let h be the function given by g of f of x. Find the value of the limit as x goes to 3 of h of x, or explain why the limit does not exist using correct limit notation in your answer. Okay, normally when we have a function inside of another function, we do something pretty straightforward. we would first look at the limit of the inner part. What is the limit as x approaches 3 of f of x? It's 2. Does anyone not see that? Everybody's good with that? Okay. And then if you're like, okay, well, that's going to 2, so I just need to figure out, well, what's the limit as x goes to 2 of g of x? It doesn't exist. Unfortunately, if you did this, this is wrong. F of x is going towards 2, and that's what we're putting inside of g of x. Okay? This is an easy mistake to make, and I've actually seen teachers argue about this. This is wrong. Now, why? Well, both of these statements are true, but does not exist is not the right answer. And the reason why is they got really sneaky. As x approaches 3, f of x does approach 2, right? But notice, does it ever approach values of 2 that are less than 2? Or is it only values of 2 that are greater than 2? As we approach 3, these are all values bigger than 2, right? Everybody agrees with that? So this actually approaches 2, but only from only values larger than 2. So this now becomes not the limit as x approaches just 2, but the limit as x approaches 2 from the right. As x approaches 2 from the right, what does g approach? 4. The answer to this problem is 4. But it's tricky. But everyone understands how that trick works? Okay? That's why I wanted to show you something like this, because it's like, hey. All right, not all of them are as tricky as others. This one, I don't think is particularly tricky, but you do have to read carefully. The table above gives values of the function f at selected values of x. Which of the following conclusions is supported by the data in the table? Notice that doesn't mean that this is absolutely what happens. It's just, does the data agree with this? So the limit as x approaches 4 of f of x is 6. Is that true? As we approach 4 from the left, what values does f approach? 6. But as we approach from the right, what values do they approach? 7. So that's not true, and this is not true. What is true is C. As we approach 4 from the left, we approach 6. As we approach 4 from the right, we approach 7. Not nearly so tricky as the other ones. Page 3. This one I don't like as much, and that's part of the reason why I included it. The table above gives values of a function f at selected values of x. Which of the following conclusions is supported by the data? Notice as we're approaching x equals 6, from the left side, what seems to be happening?
Being multiplied by 10.
Yeah, and so it's getting bigger and bigger and bigger, right? And it doesn't appear to have any limit. As we approach 6 from the right side, they become large negative numbers. Do they seem to approach the same value? Is 2,000 and negative 2,000 the same? No. So that's D. Now you may be asking, well, Mr. Davis, why don't you like this? Well, it's still possible that after you get past 5.999, that it suddenly dove towards 0, and then from the negative 2,000, it suddenly pulled up to be 0. That's still possible, but is that really supported by what's in the table? No. That's why I don't like this question as much. This next one, I like very much. Let g be a function that is increasing if x is less than 1 and increasing for x greater than 1. If the limit as x approaches 1 of g of x is equal to 5, which of the following could represent g? I'm going to start at the bottom and work up. So, is this function increasing for x less than 1? Yeah, it's going up for x less than 1. As long as I'm on x is less than 1, the function goes up as I go from left to right. Is the function increasing for x greater than 1? Yeah. Is the limit as x approaches 1 of g of x equal to 5? Well, 1, 2, 3, 4, 5. Yep. This one is just fine. Let's check the other ones. For Roman numeral 2, as we approach 1 from both sides, does g of x appear to be approaching 5? That's right. That's the right face for this. No, certainly doesn't look like it, does it? And then we have this one. You're like, oh. It tells us that g of x is 3 for x equals 1. That doesn't mean a darn thing. The value at 1 doesn't come into play in this problem at all. But let's take a look at this one. The limit as x approaches 1 of g of x is going to be the limit as x approaches 1 of x squared plus 3x minus 4 over x minus 1. If I substitute in 1 directly, I get 0 over 0. That means something is going to cancel out. So that's going to be the limit as x approaches 1 of, let's see, what would that be? X minus 1 times x plus 4 over x minus 1. Except at 1, this is the same thing as just x plus 4. So I can divide those out and replace that with 1. And that's 5. Well, that's the second part. And everywhere except at x equals 1, this is the equation y equals x plus 4. It's just a line with a positive slope. It's increasing everywhere. This is also correct. Okay, any questions about that? Yes,
Is that like a question that would be on the AP test?
could be.
And it would be if you chose either one? you'd be
No,
fine?
what it would be is you would have A as 1, B as 1 and 2, C is, 2 and 3. It'd be one of those questions. But you have to analyze part 1, 2, and 3, and then you pick, it should be, you should have a choice of 1 and 3 only. Okay? It's a great question. Yes, ma'am.
How does it show that it's always increasing?
Oh, because this x squared plus 3x minus 4 over x minus 1 is exactly equal to x plus 4 for x not equal to 1. This has a hole at 1, this doesn't. X plus 4 is a line with a positive slope, so it's always increasing. Okay? All right. Anything else? Great questions.